All right, we proceed with our 1D. D, we have a 3 question, but we start with the first one. Okay, in a double slit, experiment, if a double slit is in phase case, right? In phase case experiment, in phase case. So first range that I get, if a central max, right? Constructive interference, and the slit separation is a 0.03. Okay, and the distance of the double slit from the screen is 160 cm when a green light is used. The distance of the first bright fringe from the central max is a 0.3 cm. Okay, we'll list down all the information. Right, so I have a D equals with 0.3. 0.03, if cm, straight away I convert to meter. -2 meter. Okay, then after that, the D of 0.03 cm, 160. So D from the screen, double slit from the screen, the slit, 160 exponent -2 meter. Then after that, first bright fringe. This one is my first bright fringe, right? So y1 equals with a 0.3 exponent -2 meter. Okay, so which equation that we need to use in phase double slit experiment in phase? So the equation that we need to use is this one: m order equals m order lambda wavelength d over d, right? Okay, then we rearrange our equation to get a lambda, because the question need to calculate the wavelength of the green light. Okay, we rearrange the equation first. Okay, lambda as a subject, we put it left side. So ym, and then d, we rearrange cross multiplication. So over md. Okay, we substitute. Okay, this one, when our m order m equals to 1, right? We cannot substitute 0. Okay, we have to put 1. Okay, minimum. Okay, so this one will be 0.3. Okay, 1. Maybe you can put this one is a y1. Okay, if you want to put as a 1 straight away, no problem. Instead, you want to substitute, right? If you want to put it y1, also can, no problem. Okay, 0.3 exponent -2. Okay, then d separation 0.03 exponent -2. Okay, then over, okay, divided by, okay, m is 1, then d 100, 160 exponent -2, then equal, so answer is 5.625 exponent -7 meter, right? Okay, so if you want to put in terms of nanometer, if okay, can solve 562.5 nanometer. Okay, acceptable, right? Okay, this one is a D1, D1, right? So we move on to D2. D2, calculate the distance of the third dark fringe from the central max. Okay, central max. And we understand, and we know that double slit is in phase case. So if like this, the dark fringe that we have to put m equals to 2 or m equals to 3. Okay, before that, maybe we can explain a little bit using a diagram. Okay, so this one, let's say I draw a little bit. Okay, bear with me. Here is my S1, slit 1, then slit 2, because of double slit, right? Okay, so the distance in between, D. Right. Then after that, screen. This one is on screen. Okay, this one is a screen. And normally we put this one as a we label as a D. Okay, capital letter D. Okay. So in the middle, normally we get this one is a central max. Central max when M equals to 0. Right? Then you draw. And spacing. Okay, spacing. Okay, draw. Just to draw this. Should be the same, huh? Should be the same. Okay, should be the same. Okay. Oh, okay, you draw. Okay. Should be the same. Okay, draw like this. Okay, I draw. The spacing should be uniform, right? Should be uniform. This. Okay. So central max. Okay, this one is a constructive with the parents, bright fringe. Right. So here is the second one, dark. Dark. This one should be dark, and then this one also dark. Dark fringe. Okay, dark fringe. Right, dark fringe, dark fringe. All right. So I have when m equals 0, central max. This one also m equals 0, then m equals with 0. But we already start a label as a first dark fringe. Right? First dark fringe. This one's the first dark fringe. Okay. And when m equals to 1, okay, and m equals to 1, so we label as a first bright fringe. Sorry, first bright fringe. First bright fringe. First bright fringe. Okay, this one's also the same. And m equals to 1. First bright fringe. Okay. Okay, if you draw another one, we continue. If you continue, so when m equals 0, this one is the first dark fringe. Okay, when m equals to 1, so the bright fringe is start with 1. M equals to 1, and first bright fringe. Okay, if I draw another one, let's see if I draw another black one. Okay, dark fringe. I draw another one, dark fringe. Okay, you get another one, dark fringe. You get another one, dark fringe. So that means I have my m equals to 1, but already labeled as a second dark fringe. And down here this is the same. Okay, I draw here. Okay, when m equals to 1, second dark fringe. Okay, means that when this one they'll refer to m dark third dark fringe, so my m equals to 2. Okay, my m equals to 2. Right? The dark fringe, my m equals to 2, my order. Right? So if we substitute in equation, so what is the equation? What's the equation that we need to use? Y m equals with m plus half. Why? Because this one, the question calculate the distance of the third dark fringe from the central max. So that means dark fringe. So we have the plus half. Okay, lambda d over d, right? But our order m equals to 2. Okay, substitute 2 plus half, and the order is a 5.625, right? Just now we obtained the answer from B at D1. Okay, exponent -7, right? 160 exponent -9 over, oh, right, bear with me. Then 0.03 exponent -2. Okay, so the final answer will be 7.5 exponent -3 meter. Okay, so the last one, so this one will be our y2, therefore. Okay, is it okay? Calculate the distance of the third dark fringe from the central max, right? So y2 equals with 7.5 exponent -3 meter. Don't forget about the unit. Okay, right? We proceed with our D3, D Roman 3. Last question. Explain the changes. Explain the changes of the to the interference pattern if the screen is moved further from the slits. From the slits. Right. So the equation that we need to use is a ym equals with m lambda d over d. Right. This one is a general equation. Okay. If the screen is moved further away from the slits, so what happened? What happened to our interference pattern? If this one is moved away, move further away, so if increase, when our d increase, the letter d increase, the screen. Okay, and what happened to our fringes separation? Our fringes separation also increase. Means that we can conclude that, okay, change of the y, fringes separation, is directly proportional to d, this one. Okay, the screen, the slit, double slit, from double slit to the screen is a d, capital letter. Okay, if the d increase, so our fringes separation also increase. Okay, you summarize. Therefore, fringes separation. Fringes separation. Delta y increase. All right. Um, okay, so this one is our answer. Okay, so we can answer by putting the arrow, increasing, directly proportional. Okay, if they here double slit, the distance of the double slit increase from the screen, increase d, increase fringes separation also increase, right? Okay, this one is a concept question. The last question is a concept question. Okay, so I hope you all can solve the problem after this video. Okay, okay, thank you all. Bye.